By the end of this tutorial, you'll know the exact loop for building a boss fight like this from zero. Enemies, upgrades, combos. Every system starts as a small, testable instruction. You don't need to handwrite every line. Your job is to direct the build, test it, and describe what changes next. We'll use Claude Fable 5 and Claude Code to design the complete workflow for this browser game. But this isn't one of those demos where we type "make game," skip 3 hours, and mysteriously return with GTA 6. We're starting with an empty folder. I'll show you the exact prompts, the broken first version, how we fixed it, and how to put the finished game online so anyone can play it. You don't need to be a programmer. If you can install an app, copy a prompt, and describe why something feels wrong, you can follow this. That last skill is surprisingly powerful. Claude Fable 5 is the brain. Claude Code is the pair of hands working inside our project folder. It can create files, inspect errors, revise its own work, and run checks without us copying code between windows. First, open the official Claude Code setup page linked below. I'm using the current official installer because setup commands change. And immortalizing an outdated command in a tutorial is how villains are made. Once it's installed, open your terminal. A terminal is just a text box that gives instructions to your computer. Type Claude, sign in, then open the model menu and select Claude Fable 5. Create a new folder called BYTEBREAK, open the terminal inside it, and launch Claude. Keeping the game in its own folder matters. Otherwise, your AI developer may begin an unexpected side quest through your tax documents. The fastest way to fail is asking for your dream game immediately. We need one player, one arena, one enemy, and one reason to survive. Fun first, content later. Our game is BYTEBREAK, a top-down browser survival game. You move a tiny ship, dodge enemies, fire automatically, collect upgrades, build a combo, and eventually fight one deeply unfriendly boss. Here's the first prompt. Notice how it defines the platform, the rules, the limits, and the testing process. We're not asking Claude to guess what cool means. We're giving it a job it can finish. Claude proposes a file structure and several milestones. Before accepting, check one thing. Can we play something after milestone 1? If the answer is no, the first milestone is still too big. I approve only the first milestone. Create the arena, movement, one enemy type, and basic collision. This keeps the feedback loop short. Claude works, we test, and reality gets a vote. Claude tells us how to launch the game. Because this project has no build step, testing is simple. Start the local page, click inside the game, and move with W, A, S, and D. And there it is technically a game. In the same way that toast is technically dinner. The player moves, enemies chase us, and touching one reduces health. That's enough to continue. Except there's a problem. An enemy can overlap the player and drain the entire health bar almost instantly. This is where beginners often say, fix the game. Don't do that. Give Claude a reproduction. What you did, what happened, and what should happen instead. A useful bug report beats an emotional support paragraph every time. Claude finds the collision running every frame and adds invulnerability, visible flashing, and knockback. Now getting hit feels intentional. More importantly, we test the exact same steps again before moving on. The game works, but it doesn't feel good yet. Shooting has no weight. Enemies vanish without feedback. Movement feels like dragging a spreadsheet cell. None of these are code errors, they're experience errors. Instead of saying make it better, we describe the feedback each action needs. Anticipation, impact, and confirmation. This is the difference between asking for decoration and directing game feel. The difference is immediate. Every bullet now says, I left the ship. Every hit says, that connected. Every explosion says, yes, you may feel clever for half a second. This loop is the heart of AI-assisted development. Ask for one observable change, test it, and keep or reject it. Claude can generate quickly. Your job is deciding whether the result deserves to stay. Next, we give survival a purpose. Enemies add score. Quick kills increase a combo multiplier. Taking damage breaks the combo. Suddenly, the exact same combat creates tension because there's something to lose. A good upgrade should change a decision, not just make a number slightly larger. We'll start with 3 choices: faster fire, piercing shots, or a protective shield, damage, strategy, or forgiveness. We also tell Claude when the menu appears, what pauses, and how the choice returns us to the game. Interfaces break when we describe only how they look and ignore how they behave. Now each run develops a personality. One attempt becomes a bullet hose, another becomes a careful shield build, and one becomes a heroic experiment that ends after 11 seconds. We have a loop but not an ending. So after the player proves they can survive, the arena changes, normal enemies retreat, and the boss enters. This is our final exam. The first version is terrible. The boss appears without warning, fires an unavoidable wall of bullets, and kills me before I can understand what happened. Impressive efficiency, bad design. We ask for 3 things. Telegraph every major attack, leave a visible escape route, and introduce patterns one at a time. Difficulty should test understanding. It shouldn't test whether the player can see the future. This time the boss feels dangerous but readable. The warnings build anticipation. The patterns escalate. The health bar turns every successful dodge into progress. And when it explodes, the entire game finally has a payoff. Before adding sound, we list the moments that deserve it. Firing, impact, damage, upgrade, boss arrival, and victory. If everything makes a dramatic noise, nothing feels dramatic. Next, resize the browser. Our game currently stretches like pizza dough. We ask Claude to preserve the gameplay aspect ratio, scale the canvas cleanly, and keep interface elements inside safe areas. For phones, we have 2 honest options. Build touch controls or clearly label the game as desktop only. Pretending keyboard controls work on a phone is not responsive design. It's optimism with a viewport tag. We store the best score locally, so refreshing the page doesn't erase it. It's a small feature, but it gives the player a reason to return, and a reason to send the link to someone competitive. Then we add a proper title screen, control instructions, pause behavior, game over, victory, and restart. A game isn't complete when the main mechanic works. It's complete when the player can enter and leave without confusion. Now I ask Claude to review the project without adding features. Remove duplication, explain confusing sections, check for runaway timers, and confirm that restarting creates a clean game state. We test like someone actively trying to ruin the game. Restart repeatedly, hold 2 movement keys, resize during combat. Choose upgrades with the keyboard, lose during a boss transition, and mash every button. We also verify readable contrast, visible keyboard focus, reduced motion behavior, and instructions that don't depend on color alone. Accessibility isn't the boring task after design. It's part of whether the design works. Because BYTEBREAK is a static browser game, deployment is refreshingly simple. We ask Claude to verify the entry file, remove development leftovers, and create a short README with controls and launch instructions. Upload the finished folder to your preferred static hosting service. I'm using the service shown here, but GitHub Pages, Cloudflare Pages, Netlify, or another static host can serve the same files. Don't celebrate yet? Open the public link in a private browser window. Test the controls, audio, restart, and asset loading again. It works on my computer is not a deployment strategy. And that's the real finish line. Not a folder on your machine, but a link another person can open. An idea became a playable thing, and the distance between those 2 just became much smaller. We didn't use a magical prompt. We used a repeatable loop. Define a small outcome, build 1 milestone, test the result, describe the gap, and improve only what matters next. The opening prompt worked because it contained constraints. Browser game, no build step. Original assets, small milestones, a test after every milestone. Constraints don't limit creativity here. They stop the project from dissolving into soup. Mistake 1 is asking for the entire dream game at once. When 50 systems arrive together, you won't know which one broke the other 49. Build the smallest playable loop first. Mistake 2 is accepting the first result because it technically runs. Play it. Resize it, lose deliberately, restart repeatedly. AI makes iteration cheaper, but it does not make judgment optional. When something needs changing, use this formula. Describe the current behavior, the expected behavior, the constraints, and the test for success. That works for bugs, interfaces, game balance, and almost everything else. So this is BYTEBREAK, a complete browser game built from an empty folder with Claude Fable 5. The starter prompt and build checklist are below. Make your own version, change 1 major mechanic, and send me the link. I genuinely want to play it. And if you want more projects where we build the real thing, including the broken parts, you know what to do.